Hello everyone, so here is Sam Smart again, and today we are going to continue with our previous project on KiCad, and we had as our project scope a PCB, which is a development board powered by STM32. Let me just complete it here, and we will have a development board which has RS-485, which has pinouts, definitely GPIOs, voltage regulator built in, LEDs, programming connector, and pin headers for the pinouts. So therefore, we shall proceed with that. And let me just open KiCad. So here we had our project. It's gonna open. Might take a little while. And I'll just go in a bit of run back to see all the things that we have done on that previous lecture. So now we shall continue. So basically we have assembled everything here. We have the STM32 over here. We have the pinouts for it, and we have created some local labels which we connected to our connectors on this side, and we have a couple decoupling capacitors over here on the input and on the output. We have an indicator light for whenever the power is on. We have your push button for the reset. We have all the decoupling capacitors for the analog input and for the normal VDD. Moving forward, we have also the RS-485 part, transmit and receive, which we have here, the MAX 3483 transceiver. And if you want to know in detail what is happening here, we can go to the previous lecture. And now we'll just check if everything has footprints assigned. So you just come here to assign footprints, and then it should load. Take a little while. So if everything is assembled correctly, it should be all like this, as you can see here. But we have this connector that has no footprint assigned. Therefore, we will assign it right now. I believe it's this one. Yes. We'll just do it right now really quickly. This is the programming one. And here we have our, we need to find 2.54, sorry, 2.54 in header. Need a right angle one, so horizontal, and should be a 4-pin one. Yes. So that should be it. That is everything. And now to go to PCB, you just come over here and it should bring up the PCB page. So here is in the PCB layout part. So in the PCB layout part, here we have the update. So whenever you make changes on your schematics, you can come here, click here, and you update. So for now, if I click update, it will bring all the components with me over here. And then we have here some other add-ons that I've placed. That is not necessary right now in this lecture. It's not important. What is important is to get your PCB board setup ready. So the board setup is basically all this set of rules that your design should follow. So all these rules over here, so they are not set. So you have to import. I can import them from a previous design because I already have set them before. But if new, you have to go to your PCB and you need to your PCB manufacturer and you have to check the rules there. If you see the minimum drill diameter for wires, you come over here and you go to your design rule and you'll find all the same thing over here, and you should just copy paste it, and that should be it. So that will be your design rules. So I'll just do my design rules from a previous design and we will be back. So now I've imported all the rules. So now another thing that we have to do is, since we want this to be fitted in a breadboard, so we have to make sure we have the right pitch. So we're going to use 2.54 millimeters. That is the pitch of the breadboard. So I'll just place everything maybe here on the side, the connectors. We want few on one side, few on another side. I can rotate this to make it perfect. Then we can just arrange everything. I can make it, can make everything else disappear and then just show what is important. So we can bring over here this connector. So this the MCU, and then I can bring the CAN transceiver over here, which has another connector. Therefore, I can either, how can I make this? I think I'll keep it here for now. I just need to make sure I fix the main ones. So I think we'll go with this much. What will be the dimension of it? Yeah, that will be fine. Probably can make it even smaller by bringing this guy inside. Yes, I think that is pretty much enough, because then I can put the programming means ahead of here, and we can put the voltage regulator on the bottom layer. And okay, so we can work with this. I'll just bring up some few connectors here so that we can evenly have balanced connectors. I'll just bring up so few pin headers that won't have any use right now, and we'll move from there. Okay, so for that we just go to schematics. I'll bring 3 of them. I can just copy from this guy. Probably just connect 1 to 3 3.3. That is just because I want to make everything look even. So I'll just bring these guys out. So I'll just make one of them ground and 2 of them 3.3 volts. That should be good. And you just go and you update over here, and you have another one, and that should be perfect. So this is the basic setup that we're looking for. So we can lock these guys, and we can change the pitch to a smaller pitch where we can now move things around easily and align it. So I would like to group also these guys. I would like to group them together. Grouping, so there will be a single box. So now I can align everything with respect to this. Like I want the MCU to be right in center, I want this guy to also be aligned. So I'll just align it with the box. And I'll love to bring this guy's bit up, probably over here. And then I'll ungroup them because I need to align this guy to this guy vertically. Then I'll lock this guy, and I can now align these to these horizontally, and I can align these to these vertically. Then can be locked. I don't need these references, so I'll just delete them, and I'll lock this. So now we have the basic layout of it. So what will I do now is just have a look on how is it looking on there to see how it is looking right now. So for the pin headers, I'll get them flipped to look behind. They don't really matter right now, but I'll just get them flipped later. Okay, so this is the basic design. Okay. So now we can have the edge cut. We can make a small edge cut over here. We can get a bigger pitch, like 1 mm, something like this, and we align it here. Then we can just bring it closer in a different pitch, maybe just to bring it more inside, like that, and do it over here as well, like that. It's looking pretty the same. You can do the same on this side, and we can do the same on this side. That seems perfect to me. And for this part guy, we can put it over here, like so. Can bring this guy, and we can also lock all these four together, like group them, so that they'll, because they're not going to be moved anymore, so you can group all of them together. So now this is what we are working with. This is what we are working with. So here you see these pins are shifted. I'll not like that. And we have here, so I can have this guy like this, because then I'll go back to schematics, because these wires are shifted. I can just have them oriented differently. So for that I'll have to rotate this, put it like this. Doesn't look the best, but that's how I just quickly do it without having to do many things. I save it, I come here, I update, see, now it's coming perfectly in line. We have to get the resistor, 120 ohm resistor. Let's just bring it over here. Can put it over here right in front, but it's best to just keep it right close to terminals, like that. And I can bring this guy down like this, and I can also bring the decoupling capacitor. So how I do it to get everything closer very quickly, for example, now I'm working with this guy, so I can just select all the components that are around here. For our case, it's just these two, so I'm looking for my decoupling capacitor for that guy, so just bring it close. I like to keep the decoupling capacitor as close as possible, so I just keep it right here in front. Can change the pitch now to something smaller. I like working with some smaller pitches. I'll lock this guy in and I'll just observe to see how everything is looking. So now we have the edge cut all set. As the programming mode means all done over there. Okay, it's not looking bad. I can bring the values over here. It's not looking bad. So now we can, oh, let me think. Let me just think how it is. Still don't like how it looks though. But, and I don't think that this guy needs to be behind this. So I can just bring him over here. Although the VCC voltage input is, I still think that I can still put it on him over there. Bring this in middle. You can bring this in middle. You can keep it outside like this. This guy, I'll just bring it down here, and then I'll align it with the box. And then I think I'll lock it. Yes, this guy is ready to be locked. Actually, I would like to get them flipped so that, let me unlock them. Control L. I'll unlock them. I don't know why I locked it again. I want to ungroup them. Then I can flip this guy to the bottom layer, and can also flip this guy to the bottom layer. Can flip this guy to the bottom layer. Bottom layer. So everything is now on the bottom layer, except this guy because this guy can stay in front. It's perfect. We have our switch here for the set. Where is our reset pin? It's over here. I think I would like to have the reset button right in front of the, I would like to have it over here somewhere. Can have it over here somewhere like this. Maybe shift it like this. I like to have also the power LED and the, just come and select it over here. I'll also select these ones so that I can just isolate them, and then this one and just bring it somewhere here, and the other one and bring it over here. Don't worry about the labels now, it's not important. Okay. So this one is the power LED and the other one is the blue LED, the built-in LED, sorry. So I'll just get these guys aligned. I like them to be beside each other. And to get this aligning option, you just need to right click on, you select both components like here and here, and then you right click and you go to align. So you have here our resistor, you can put this on the side, not necessarily needed to be done now. Just put this MCU here. These guys, they can actually disappear. I love them to disappear. Don't want them to show around because I will put some different labels on these guys. And we have a pull up connected to the reset, and I'll just keep this pull up probably on the bottom layer. Just keep the pull up on the bottom layer. Keep the pull up on the bottom layer. Do I need to keep it on the bottom layer? No, I have space in front, but I would like to keep it clean. Also, these resistors, I'll keep them on the bottom layer. Actually, in fact, I can keep them in front so that reduce the bias. Decoupling capacitor for the MCU. Now, come and select these guys. Just line them up. Organize them. Very good. I can now select all three of them and right click, distribute vertically so that they will have equal spaces. This font size is actually too big. You can make it 6.8. Copy this, paste it over here. Okay, and do the same for the other ones. It's perfect. Now I can bring them, I can flip them to the bottom layer. Now bring them close to the pin where they're supposed to be connected. Keep this guy somewhere. I mean, this is in front, so it doesn't matter actually. And the same we have to do for the other capacitor. Into 3.3. I'll flip it. And I'll bring it close to that input. Looking for this guy. So that is the input. Where is the VDA? Looking for this guy. Okay, so we have to bring these three somewhere here. We have to bring this guy somewhere there, like this. Perfect. I think this guy can stay in the bottom for real. Can unlock this guy. Can maybe work him around. But put in outside for now. So what I'd like to do is just arrange them perfectly. So I'll come back after I get everything arranged perfectly, and then we'll move from there. So we have here everything roughly assembled, and right now we need to put some copper pores where the top layer will be the ground plane and the bottom layer will be the 3.3. So we'll just come here in the stack up, just make mixed on both sides, but bottom one mostly power plane. And then so to make a copper pore, you have to come here to fill zone, then you just select one corner whenever you want, and go. I actually have to cancel it. Come here, select it, and then we put GND on front. Everyone solid fill with thermal reliefs 1.5. That's the minimum. Shall make it for the 3, 3, and 5 is fine. Reference 0.25. You don't need to change this data. I'm changing because of the size of it. I should make it everything going 3. Yeah, solid fill. So you just need to go around here and just follow this reference. right click, close outline, and I can copy the same outline and click E to edit it. So now we want the same outline on the bottom layer, make it 3.3 volts, and then just align it over here. And then just click B. The copper pour should be done. So now I'll have to run this solid. Just make sure, now I'll have to make sure that everything that I want is aligned. So we'll go for back layer. We don't want to see this, we don't want to see this, we don't want to see this. So now we have to make sure everything is aligned in center, because no specific reason, just want to make it a bit aesthetic. Can bring it somewhere here. And then we click B to preview zones. If I just go out 3, I can see everything how it's looking. So now we'll get to the routing. So I normally go for the 0.3 trace thickness. So, and I'll start with the most important things. So therefore I'll just start with these guys. I'll route them from behind, pull out the Y over here, put it there. Why am I routing behind? Because we have these LEDs here that we need to work them out. Same thing, just do this guy, put the Y over here, route them straight up. Nothing crazy. You can even just bring it here, and then you can make it more straight actually, like that. That's done. And then that's the first task. We now go for the U outlines. So for that, just come over here. I'll bring this guy over here. So it's creating a little bit of conflict. So I'll write this guy together. I'll bring it outside. I should pull a wire. I'll bring it outside over here. No, we'll do this one last actually. Let's just route the power. We need to pull out the wire. So for that I have to make this. I need to move it a little bit. And then I need to pull a wire over here. Let's route them all together. And for this guy, just pull the wire here in the middle. We just short it. I'll pull another wire here. Maybe not necessarily. For the reset, I'll actually bring it forward again, because no reason to be behind. Just route these guys. So I'll change these two because they are interfering. So I'll just move these guys here. Connectors. So I'll make this guy come. Let's swap these two, and I'll swap these two. Save it. Come here. Update. No, not here. Now it's perfect. So now I can just route this straight up like this. And do the same for these guys. And for here, just pull out a 3.3 over here. We'll do this over here. Like that. And get a little bit closer like this. Yes. That should be perfect. For this one also, just come down. And now we have a little problem here. So I'll swap this guy to come above. So PA4 and PLED. PA4 and PLED. Let's swap them. Save. Update. So now it's straight. This is coming like that. Perfect. And now for these lines which are conflicting, I can actually do this. I can route this important one first, putting a wire over here, and I'll have to put in another wire here. I'll probably pull this guy down first. And then okay, there's some space now. We can now bring this guy like this. Easy. So I'll probably take this guy out, put a wire, bring it somewhere here. So I have those guys on the bottom layer, but I can actually improve this by shifting these guys to the other side like this. And route it differently like this. So now I have free space to work out on this side. Because this is just a digital line, I can put it a bit farther just to make up space for the wire here. Now I can put a smaller grid just to see if I can make this a little bit more streamlined. Not the best, but I have to work out with whatever I have here. So wires are basically connecting the back part of the PCB with the front part. So I'm just gonna keep them short like this. Okay, and I'll bring some ground wires here in between just That's good. That should be fine. Okay. I think I'm satisfied with that for now, and I can just bring this here in this guy, in this here, and this guy, and then get my decoupling capacitor for this. See, I don't know where I placed it. Go back to that layer, just connect this. Let's make a connection like this, make a connection like this, and a connection like this. And I'll just pull up wires for these grounds. For this one, just bring a little bit bigger wire. Like that. Now we'll have to look for this guy, where it went. Oh, intruder on this way, on the other side. This guy has to be here, smaller trays. Over here. And I just need to just put a wire here. That should be it. We need this one, this, and for the ground, you know what to do. Just a wire, because actually ground is in front, so I should just pull out this guy and do this. So now we have this. Let's see. Okay, no isolated islands. Not complete. We will just have to start our reset, which can be a smaller trace. Just route it from behind like this. And our LED can also be a smaller trace. Just need to create some space. We need to work it around. Probably I'll just bring this LED below here and take all these four guys, rotate them like this. Wow. I'll rotate them like this so that I can just route this LED around. Maybe stop there, just move this guy a little bit. Delete this unconnected. Wow, why is that happening? Okay, and that should be done. And then I'm just connect this to this, these two a ground, this to ground, these guys together, this guy to a ground. So sister can come over here. Actually, we don't need this. And you can put it as a smaller one. You can put it. And you can do that to everything. Like, just make it smaller here. Just put it over here. Preferably, I'll just remove them. You need them. Avoid the wires carrying the screen, carrying the wires being covered or being interrupted by the silk screen. So therefore I'm doing that. I'll put here just a text, power power, use it. This guy 0.8, 0.8. Want it on this thing. Just keep see power LED. Okay, just copy it to keep the same font, and this will be, that should be name of the pad. Just go here, it's PA0. So that is aesthetics, not mandatory. Do that aligned. Here our reset button. First we have to route this before I forget. And we can move this guy towards here. 0.8. Just make all of them that are visible the same size and put them with more elements. And I like these guys to actually be a little bit more like this. I'll unroute this guy and I'll unroute this one. I'll also unroute this, unroute this. Let's make sure this is in center. Actually, let's just bring it over here. I'll route this and I'll line this with center. But ideally, this should be close to the terminal, so then I can put back this size. And this one most likely just be straight. Like this. That's perfect. That's better. Not so different, but whatever. And here we have everything about it. Now I can just maybe rename this, give it a name, like just call it here, just call it SSL node. Actually, I'll call it node mini. I can lock this and align this with that as well. Mini. And we can have here also a reset every time. Over here. Can bring up our logo. here. And now the rest is aesthetics. You can name all these pins below. You can write the label of the pins over here and over here below or above, your choice. And but for the video, sorry, this will be all. And we can put some stitching wires if needed, like grounds. Just spread them around. It's good to have stitching wires. Put it over here, over here. You can just spread them around. Necessarily for this PCB, not really, but if you just remove this one, so there's great problems with the islands. Yes, you can also go to the back layer and you just adjust these guys like this. Double it like this actually. That'll be it. Everything done. So guys, this will be it for this video. And here we have the SSL node mini. And in the future videos, we'll expand this project with the same base for something a bit bigger, and we'll try catch up on more PCB tutorials. Thank you for watching, and I'll see you next time.